in the classroom in like real world like applications, I guess. Um, that's also like good for like networking. Um, and just I don't know, something something you don't really like get in a traditional classroom setting, I guess.
Yeah, so that's a big part of it is honestly, if you wanted to look at it as like what can I gain out of this, it's just trying to boost the transcript because the extracurriculars matter a lot. Like, what was it? We just like there was a girl yesterday at the Sierra College like honor society meeting, and she got into Yale, and she's like done a whole bunch of extracurriculars. So, like literally from Sierra College in Rockland, now she's going all the way to Yale. Like a lot of things are possible as long as you apply yourself. And so Hannah and Sierra are the presidents. I'm gonna be vice, and we'll work out the roles from there. Hannah has created a Google Doc that she can post when she has the time. You can just fill it out if you're just interested. It just has just general information, and that's about it.
I'll say
Um,
one more thing. And also, as far as roles, like anyone can have any role basically. And if you don't want a role, that's fine as well. Like you don't have to have one. But if you would like that for your transcript, like specifically to look better, like that's available for you as well. Carol, I see that picture of yours.
Sierra, no, don't start. Oh,
No, look at it.
I know. But that is it.
Yeah, I guess if you have any questions, you can just contact me, Sierra, or Dexter.
Yeah, we've already talked to Calabrese about all of it, and that's it. If you're just interested and just like want to do like cool related shit with it, then that's it. All right, thanks, guys.
Yeah,
So
bye.
I'll start this problem now. This first one I ever showed you in review. It's probably like 10 people that showed up that day before extra credit was involved. So we have a black car traveling east at 21 meters per second. An orange car starts from rest and accelerates east at 2.0 meters per second squared. When it is 540 meters west of the black car, when do the cars meet? So as always, with everything, I'm gonna draw a picture. I'm gonna draw orange car from rest at the origin, and then I'm gonna draw my black car. If it's west, or if the orange car is west of the black car, then the black car is east of the orange car, and the distance in between them is 540 meters. And off to the side, just general information for myself. I like to write my knowns. So V naught for black car is 21 meters per second. Its acceleration, I'm just going to say in the x direction, it doesn't have any, so 0 meters per second squared. X naught, its initial position of where it starts. If the origin of my Cartesian coordinate compass here is 0, 0, then over here, where the black car is, it's going to be 540 meters. Or if you want it like this, that works as well. And then I'm going to have my knowns for my orange car. So V naught for that is 0 meters per second because it starts from rest. Acceleration initial, it's constant, 2.0 meters per second squared. Its X naught position is going to be 0 meters because it's starting from the origin. From there, I can write, well, keeping in line with what I do in the class, I want to know when do the cars meet. So when they meet, that means my goal is a time value. So I'm solving for just a time. So if I were to write a velocity equation for orange car right? In general, I have v, and then I have v naught plus acceleration times time. And filling that information in, let's say this is orange car, VO. V naught is 0 meters per second. I'm just plugging in everything I have. And then for the black car, V sub capital B, I'm going to have same thing, just filling in this prior equation of V naught. V naught is going to be 21. And then acceleration times time, it doesn't have any, so it's just 21 meters per second. And so when they meet means that they have the same position, correct? So that means x of orange car equals x sub b of a black car, and these are positions. And so to get a position from velocity, I just take an antiderivative. So I said v antiderivative v sub t equals xt, which taking antiderivative of this is just power rule with respect to time, right? T, the degree of this is 1, so I would just add 1 and then divide by that, which is 2. So I'd be left with just t squared. And if I really want to be thorough, 1 meter per second squared. And then doing the same thing with v sub b, antiderivative of it, I will write, and take just antiderivative. That doesn't have a t, so it just adds a t to it. So I'll say x sub t orange, x sub t black, times time, 21 meters per second times time. So far this shouldn't be too bad. This was, months ago, but it's just kinematics. It's not even like a rocket problem or anything. And from here, I just set them equal to each other, right, and solve for t, because that's what these are. My goal initially is to find for time. So plug in what I know. T squared, 1.0 meters per second squared equals, correction here, okay, antiderivative on this guy. Technically, these should have a plus c, right? And that c is going to be their initial position. This one's 0 because it starts from rest. That's the orange car. And starts from the origin. But for x sub b, this initial position is what's given in our knowns of 540. So when I take an antiderivative, I don't have bounds, then I need to add the plus c constant. In my case, it's just initial position. Solving for this, I'm going to move all the terms to one side, set equal to 0. It's going to be a quadratic. And I'll just take the value that makes sense, because you shouldn't have a negative time value. Doing so, just quadratic equation, b squared plus or minus, or negative b plus or minus b squared. And this is a, b, c. Might get lazy with units because this is just repetitive to write. For AC, to A, then, yeah, at this point, I mean, you have a calculator. You should be able to plug it in. It should reduce down to just 21 meters per second plus 51 meters per second over 2.0 meters per second squared. You'll see this has an extra factor of seconds, so multiplying by reciprocal, all that's left is going to be just seconds. And it'll be 36 seconds. So if I want to follow his 3 sig fig rule, that's it. The cars meet at 36 seconds. And so that's just honestly as simple as it can get. It's just a kinematics equation in one dimension. So that's to start it off. Does anyone have questions with that? Big, small, doesn't matter to me. But I mean, literally less than a week now. All right. Post the next problem up now. And once again, I'll give you just like 5 minutes or so to see if you can do it on your own or even know how to start. When I got this exam back, I wrote some red pen notes down. Some notes down in red pen for myself. And so those might give you a hint on what to do. Are you all good? It's like eerily. I get you're all muted and everything.
We ballin'.
All right. Thanks. All right. So I'll begin. I have a particle P moves along a circular path of radius r equals 24.00 centimeters at a constant speed. It completes one revolution in 18.0 seconds. The particle started from point A, see figure below, Determine the position, velocity, and acceleration vectors at t equals 12 seconds. Express your results in unit vector notation. So with this one, I'm just regurgitating derived formulas at this point. So let's see. My goal. I need to change this font size now. My goal is I want r hat, I want a v hat, or v bar vector, r vector, and then an acceleration vector. And this goes as bracket, and then r cosine, and then what goes inside this cosine wants to remind me.
Isn't it omega t?
Nice. So I have omega t. What I'm going to add is just my own personal term. I'm going to say plus v, because usually when we do these problems, it starts here. And so I can just call that like 0, 0 on a unit circle. But in this case, it started pi over 2, 90 degrees at whatever that point is. Well, in my world, this is pi over 2, just because I'm calling the 0. So r sine omega t. Once again, I'm adding my little phase shift angle. And like before, to get position, take a derivative of, to get velocity, take a derivative position, to get acceleration, take a derivative velocity, and so forth. So I just need to solve for omega. I know in one revolution, I go takes 18 seconds to go in one revolution, so that's my period. I have 2 pi r over time. That's velocity. And then I know if I take just unnecessary information, but velocity is just omega times radius. So if I just remove the radius from this guy, that means just 2 pi over t is omega. Plugging 18 seconds, 2 pi over 18. 2 over 18 reduces to pi over 9. So from there, I'm going to do everything in centimeters. So I'll just say right off the bat, r bar equals 24. I'm not going to write the 0.00. I'll leave the units at the end of these brackets. So r 24 cosine omega pi over 9 times time plus what I'm going to add is pi over 2, because that's where I start from. I start from 0 pi over 2. And if you just do the mental math in your head, you'll get the same thing. So I have this. If I want to take a v bar, I just take a derivative with respect to time. So all I'm doing is multiplying this 24 by pi over 9. The pi over 2 is a constant. It has a time t value associated with it, so it does nothing. And when I take a derivative of cosine, I get a sign change, so it becomes negative 24 pi over 9 sine pi over 9 t plus pi over 2. Like I said, I'm being thorough about this. If you just wanted to skip straight to plugging in your time value of 12 seconds, go ahead. This is 24 pi over 9 cosine all this stuff in here. Really nothing crazy. Let's see. Acceleration vector. All I'm doing is multiply by another pi over 9. So I'll have 24 pi squared, 9 squared. This is cosine time plus pi over 2. And follows the same over here. So I just can solve for two different values, I guess. When I plug in time, I can solve for a cosine of this and a sine of this, and then just substitute them in. So off to the side, I have cosine pi over naught at time equals 12 seconds, right? So just plug in 12 here. It's pi over 2. And I'm just going to do the same. That way I don't have to keep writing this. I can just start plugging this in over and over again. Your answer will be like in decimals, but I'm not going to take the time to do that. I'll do it for like R bar. Let's see. Cosine. This reduces to 4 over 3. Plus pi over 2. Same thing. What I'll get is 11 pi over 6, it looks like. If someone wants to verify, let me know. Cosine 11 pi over 6 is going to be root 3 over 2. Sine of 11 pi over 6 is negative 1/2. And so I'm just going to plug that in over and over and over again to where they are. So for R bar, I'll now say at 12 seconds, R bar is 24 times root 3 over 2. And this is 24 as well, times 1/2, negative 1/2. And what I should get, this is 12 root 3. I hat, because it wants it in unit vector notation. So I hat is a little unit vector of just 1 in the x direction. And this would be minus 12 j hat. And then one thing I cannot forget is these all have units of centimeters. And you would do the rest from there. Value shouldn't really change much because you're always multiplying by 24. Did anyone get a similar answer? I just did this one off this. Anyone? By chance? I make a mistake, let me know. Y'all can hear me, right?
Yep. Just looks good.
Alright. Did anyone get a similar answer? That's how I know y'all didn't do it.
We all just sitting here watching and doing nothing.
I mean,
Yeah.
I just didn't get to the point, so.
No, that's all good. But you would plug in the rest
They are talking in the chat, Dexter.
Yeah, I did. I'm just watching for now. Y'all scared to speak? It's okay. Me too. All right. Thanks, girl. This one's familiar because I made someone on the board do it, so I regret doing that because I don't think they're aware that a whole class was watching them, and they did it right to an extent, but now I know. I'll include the little picture with this. I'll say it's spinning like this in that little picture you can see. So a small block of mass m rotates inside an inverted cone whose axis is vertical. The mass traces a circular path and the time for one revolution is t. The walls of the cone are frictionless and make an angle of alpha equals 30 degrees with the vertical. What is the value of t such that the block maintains a constant height of h? Express your answer in terms of the given quantities and any numerical and physical constants. You should start a podcast. You're hilarious. You guys could be like my guests every week. And just sit there, bring up your exam score while you look nervously in the camera. I'm kidding. Don't report me, I give you extra credit. So one thing I want to note with this previous problem, the reason I just did it straight off the head and asked if people had answers to compare with, is that I didn't account for this phase change angle, this pi over 2, So in my answer, you'll only just see the pi over 9 times time. I think some of you have seen that before. And so it'll be different values, but if you were to add pi over 2 in here initially, you'd get the full credit for it. But he didn't take much off for that because the rest of it was right. And here we go. I guess I'll highlight information that I like. Alpha is 30 degrees. My goal is a value of time. It maintains a constant height of h. Completes it in one revolution of t. And from there, first thing I'm going to do, even if I don't know what to do, is I'm just going to draw a picture. So my little free body diagram. I have my slanted mass. Little m. Going straight down. Let me pick a different one. So going straight down, I just have mg. And then I have normal from the surface, right? There's a surface here. And so opposite of mg, I'm going to have n, a component of n. And then this way as well. I'm not filling in the angles yet because I need to be a little thorough about that just because everyone's trig is a little different. So I have this, and ideally I want to know what this angle is. So before I can fill out the rest of these, and then I can call this n cosine of that angle and then n sine of that angle. I look at my little picture here, and this is alpha, and there's a 90-degree angle here. And so there's a little triangle that's formed right here. And so this is some other angle. I'll say that's beta. And if I extend a line upward from there, so dash line, dash line, dash line, going upward, and then I draw my own little normal line from here as well. There's normal. I'll see that you can tell by this blue corner, there is a 90-degree angle here. And so if all sides of this triangle add up to 180, right? That means this is beta. Over here on the other side, this is alpha. And so what I need to do with this guy is then same thing. If these two in a different color, different shade of blue, if this makes another 90-degree angle as well, and I know before that beta plus alpha make a 90-degree angle, then over here, another one, I have alpha, then this is beta on the other side. Or you can build a different similar triangle where you would get alpha there. Does that make sense to everyone? If I look at this picture, there's my normal line. There's my normal line. So that means to the left of my normal line, in that little angle spot, is beta. And I'm calling beta. Beta is just 9 degrees minus alpha. This might bore some of you, but you know, anxiety taking exam is real. So beta is roughly 60 degrees. I'm not going to put that in for now. I'm just going to say that's one of my knowns off to the side. So cosine beta, sine beta, question mark disappears, beta. Have my little free body diagram. Now from there, even if I don't know what I'm doing, let me just sum the forces, right? So with that, keep it in frame. Sum the forces. I'll do this one first since I don't need to ask a question about it. In the y direction, I'll say that binomial convention, positive is upward, down is negative. I'll say positive to right. So I would have n cosine beta minus mg equals may. However, my object is not hovering in the air or flying, so it's staying at this constant position. So acceleration in the y direction is just going to be 0. I can solve for this by saying n cosine of beta moving mg to the other side is mg. So this is, oops, forgot that. Summing my forces in the y direction. Likewise, I need the same for the x direction. And I'm looking at this, and I would have summing my forces in the x direction. I would have positive. I'm saying positive is going to the right, so I would have n sine beta, and then there's no other term going to the left, so I would just set that equal to m a x, a sub x. But how would I rewrite a sub x? It's spinning a circle.
E squared over R.
Yeah, thank you. Or centripetal acceleration. Either one works, but yeah. One thing I will say is I'll write what you said. I can write it as that. V squared over R. But do you have another way to write it that involves a period of revolution? There's one more way that accounts for circular motion. I'm going to write it as m and then a centripetal equivalent, but also as omega
Dingy times day.
squared times r, right? Well, I want to use this because in a previous problem, if I were to just list out my knowns, I'm given the period. There's just time. And then with that, I have omega, which is equivalent to 2 pi over t from before. So now this is a known. All I would need to solve for then is just r. So I need omega squared. I guess I can just do that now. Omega squared, just square both terms, is 4 pi squared over t. So nice. I still need to know what r is. So I would rewrite this as n sine beta equals m 4 pi squared over t. Oh, that was squared over there, huh? T squared times r. So I need to know what r is, and the rest will follow suit. So what would r be? If this is axis rotation, r is the distance from this block to that axis rotation. So I need to draw another picture because I lit that other one up. There's m. That's r. And then I'm given, what I know is that this block maintains a constant height, draw more accurately, of h. So there's r. This height over here says h, but that also means that this height right here is h. So drawing that on a neater picture, I have r, h. Then I have an angle here that I know as alpha. So just using trig, I would have tangent, because that's opposite of adjacent, alpha, opposite, r, adjacent, h. And now I can just solve for r, because that's my unknown. Trying to use just things I know, because I'm trying to solve for a value of t, right? So I'm trying to incorporate time. I get you had v squared over r, but I need some value on which I can solve for t, and that uses t. Then over here, you could do this whole problem with r, but we don't know what r is. So I need to solve it in terms of given quantities, and which is h. Plugging things in, I'm just going to write everything so I can see it all on one screen. I know r is equivalent to h tangent alpha. Let's see. With my y equation, I can solve for n, because I don't know normal force as well, right? So solving for n, currently I have n cosine beta equals mg. Divide both sides by cosine of b of mg cosine beta. And I can just plug in what I know. I know alpha is 30 degrees. Beta is 60 degrees. I'm just going to plug all of that into this highlighted equation. So n is mg cosine 60 times sine 60 set equal to m 4 pi squared over time squared times r, which is h tangent of 30 degrees. I'm trying to solve for time. You can see that some things will cancel out. So that mass goes away, this mass goes away. I realize this is independent of its mass. Pretty cool. I'm going to multiply t squared to the other side, because I just want in the numerator the t squared. Sine of 60 over cosine of 60, sine of same angle over cosine of same angle, that just reduces down to tangent 60. Over here I have 4 pi squared h tangent 30. Now I just need to divide by that. So then p squared equals 4 pi h tangent 30 degrees over tangent. Forgot to divide by this gravity, but this should be t squared times gravity times tangent 60. Okay, cool. And then P, square root both sides. Actually, before I do that, I'll solve these tangent values.
Did
So I
you
have-
lose a pi squared? Oh, you just fixed it. Never mind.
Yeah. Tangent of 30 degrees. That's gonna leave me, if I were to just draw that before I just spout it out. Let's say this is 30 degrees. Tangent of it, just due to ratios, that's 1/2. This is root 3 over 2. If I have opposite over adjacent, 1/2 over root 3 over 2. Same denominators, or the denominators just cancel out. So all I'm keeping is a 1 over root 3. So that's what I'll have here. 1 over root 3 g, and then tangent of 60 degrees, it's just this flipped upside down. So it's again for visual. 60 degrees just flips everything around. So instead of 1 over root 3, I get the reciprocal of just root 3. So this is just root 3 t squared. Root 3 times root 3 is just going to give me 3. So I'll have 4 pi squared h over 3g rooted. And I have the period at which the mass will stay at that constant height h. Does anyone have questions on that?
Is it stated that there's no friction in the system?
Yeah.
Cool.
And then the last one for today is a collision problem. So this one might be more fresh since I did it recently, or I guess last month. And then I'll just draw the two little objects. So I have this guy, which is v sub 01, traveling east, and then the other object is this one of v sub 02. Alright, let's do this. One thing I want to say while I'm on the mic, I'm the greatest pest peer of all time. A 5 kilogram particle object traveling east at 6.0 meters per second collides a 3 kilogram particle traveling 60 degrees north of west at 4.0 meters per second. The particles collide and stick together. What are the components of the final velocity of the system after collision? What is the direction of the final velocity vector? Yeah, you can put Chiara on there, but she ain't getting you extra credit. So with this, if they if they collide and stick together, that means off to the side. This is perfectly in elastic collision. So what I want to do right off the bat is this was the given picture. I'm just going to write 60 degrees in here. I'm going to draw myself a little coordinate system. Positive to the right. And from there, I'm just going to use conservation of momentum. Since it's perfectly inelastic, I can't use conservation of energy with like the kinetics, so I can do everything as such. What I will do is just break things up into their vectors as I do this. So with conservation of momentum, I'm going to say delta P in the x direction in just general format is going to be m1 v1 x naught plus m2 v2 x naught. Leaving them as m1 and m2. If you're questioning why they don't have a x naught initial, it's because, or a not initial in general, is they don't lose mass, so it just stays as it is. With that, perfectly inelastic, if they stick together, it means I can combine the masses of m1 plus m2 and then v sub x final. Likewise, just repeating the same thing, but in y land, m1 v1 x naught plus m2 v2 y naught equals m1 plus m2 v sub y final. Fill in this little picture just for myself. I'm going to say this is 5, and it's traveling at 6 meters per second, 5 kilos. This one was what again? 3 kilos. And 4 meters per second. So call this equation 1, equation 2, and just solve for them. Just plugging in what I know. So working with equation 1 at the moment. I'm going to say this is M1 and then this is M2. So plugging in M1 information, I'll have 5 kilograms. Debating if I want to write these units, but I'll do it. Times 6.0 meters per second minus over here, this vector is at an angle, so I need to resolve it in xy directions, which isn't too bad. In the x direction, this is just going to be 4 cosine 60 You can't use kinetic because it's perfectly inelastic. So it's the energy is not conserved in that way, but momentum is. Yeah, if I do a problem tomorrow, then I'll show that. But this is force sine 60. So taking the y value or x value, I have 4.0. Actually, I'll write it in the way I have it. I'll take the mass first, so 3.0 kilograms times 4.0 meters per second times cosine of 60. And I'm setting that equal to the masses combined. So 5.0 kilograms plus 3.0 kilograms, all times Vx final. I can solve for this. So what I'll get is 5 times 6, 30 kilogram meters per second, minus what I'll have as cosine of 60 is 1/2. So if I have, this is 1/2. If I have 3 times 4, that's 12. 12 divided by 2 is just going to leave me with 6. So that's just 6 kilogram meters per second. I set that equal to 8 kilograms times Vx final. Solving this, 30 minus 6 is 24. 24 divided by 8, I should get 3. The 3.0 meters per second Vx final. So that's one done, and I just do the same for number 2. Keep in mind that this isn't my final goal. I just boxed it, but I want the direction of the final velocity vector. So this is merely just a component. That gets me the components, and then I want the direction overall. So 2, plugging numbers. M1 is 5.0 kilograms. And in the y direction, though, M1 doesn't travel at all in the y direction, so that's just 0. So this whole term goes away. Minus, oh, I guess not minus. This is plus, because for this object, it's moving upward, which I defined as positive. So once again, 4, 3 times 4 meters per second sine of 60. And while this over here, this mass didn't account for any momentum moving in the y direction, I still have the total mass overall of m1 plus m2, which I found out was 8. So I'm just going to put that part in. 8 times v y final. What this reduces down to is this is root 3 over 2. So this factor of 2 will go away. And so I'll just have 2 times 3 times root 3. So 2 times 3 is 6 times root 3. I'm just leaving that as it is. And I'll say this kilograms meters per second equals 8 kilograms By final. There's nothing crazy with this. It's just using these two equations, and from that point, it's just algebra. If I solve for Vy final, I'm not going to get a pretty answer. It'll be roughly 1.300 meters per second, or like 1.299. And so final velocity in these components, I'm just putting these two together. So V final, I'm going to say is 3.0 I hat plus let's see, 1.30 J hat. And every step you do, please double check units. It's just your answer doesn't have units. Just look in the problem. You were given units in the first place. So that's the first part done, and then to get the direction, I'm just gonna be really thorough here. If I plot these, I would have a Vy final going upward, a Vx final going to the right, and so vector addition tip to tail, right? If I were to redraw that picture, it would look like that. And so if I want the direction, let's say with respect to I called this east, this was north. This angle right here is like north of east, and that would give me some sort of direction. So to do that, I have opposite and adjacent. I did that before, so that's just tangent inverse. So theta would equal tangent inverse y component. Guess I'll use this one. I'm not including the units because if they're in a fraction, they'll just cancel out in the first place. And I'll get roughly 23.41 degrees north of east. And so that's that. Does anyone have questions on this? Just realized Donovan called me Dexy. I'm doing different problems tomorrow. I'll post my solutions in like announcements of what I just did. These are all problems you've seen before, honestly. And that's it. I'll do different problems tomorrow, probably a block like going down the slope with friction, with a spring, and all that. I won't do a gravitation just because you have an hour lecture video that's provided, and I think that'd be way better than me doing a gravitational problem. Also, given the fact that you're just literally regurgitating number 18 on the exam, so that's like a free points. So if we like think about it, right, like what's the points you have guaranteed? You have that problem guaranteed, and what is that? Maybe like 25 or 20? And then you have all the extra credit, so I'll say extra credit adds, I have no idea, I don't know, plus 8. So that's like roughly 30% you're given. And then from there, it's like you choose from 5 other problems or so, or 6 problems, of which 4 you want to do. So 30 points, so it's a 30-point gravitational problem. So you get like, with extra credit, you're nearly at like 40% of the exam is, I'll say given, whether or not people agree with the word. And then that's it. You gotta clutch up at that point. Pick the problems you know. Like just because you start a problem, you're like, I feel confident in this, but if you're not like writing down enough information, just cross it out and move to a different one, and which you think you can get more information. Because remember, you're like given points on how much you know about what to do, whether it's a picture or whatever. So
So I know you touched on it, but just to confirm, you don't know exactly how many extra points we are getting from attending these reviews.
Carol says you get at the end is a total of 8, so I guess it was like
Okay.
2 per. So that's still a lot. I mean, our final didn't have extra credit, I'll say that much.
Sure.
And that's it. I'm doing this again tomorrow. I don't know what time. Probably the same time or figure out something. It'll be different.